Hi, my name is Carla Nascimento and I am a researcher at Molde University College. The objective of this video is to provide some context on the difficulties to set up a digital twin and its limitations, but also what opportunities to expect and how to better use them. This lecture will start with a simple explanation of the structure of a digital twin, followed by the role of a data acquisition and model building in a digital twin context, and last, we'll list the main challenges and opportunities when setting up a digital twin. First, I will give you a simple explanation of a digital twin structure. Digital twin can be defined as a digital representation of reality and should include all information concerning the system asset that could be potentially retrieved by inspecting the real world. In a digital twin, the data flow is bidirectional between the two items and the objects are fully integrated. The digital object might also have a controlling function with respect to the physical one, and furthermore, a change in the state of the physical object leads to a change in the state of the digital twin one, and vice versa. There are three main counterparts. First is the reality, as we can see in the figure on the right, the object and the scenario that needs to be analyzed. Then we have the physical environment, which is the simulation of the reality of the real world to be analyzed. Finally, we have the digital environment, which is the virtual representation of the physical environment. A digital twin uses simulations models to project possible behaviors of the real system using data collection and evaluation process as an internal part. This means that the digital twin is constantly updated. A digital twin as well can help to master uncertainty and maximize chances of success by taking informed decisions through a digital copy of the reality. The coupling of the physical and the digital world enables you to monitor both systems, prevent issues, develop new opportunities, and simulate future outcomes. It also provides a reliable environment where one can assess optimal operations conditions. It's based on three pillars: connectivity, digitalization, and intelligence. The best way to study the impact of new technologies is to employ simulation models that enable you to study their effects in complex contexts and monitor decisions over time. So a digital twin can help you manage uncertainty in our world. In order to manage uncertainty, data creation is fundamental for the digital twin. Data, information, and knowledge are materials that link the physical and the virtual environment. The transformation from data to information is one of the most important activities in every culture and society. The digital twin architecture typically includes sensors, measurement technologies, and machine learning. Taking a computational perspective, digital twin needs both data and information fusion techniques capable of transforming raw sensory data into a high-level understanding and insights. The challenge here then are the data types. Data creation is fundamental for the digital twin. Different stakeholders, including, among others, governmental actors, road operators, fleet managers, and even private companies in general, are interested in using detailed, precise, and up-to-date data. Therefore, there are several issues to deal with when aiming for a shared vision on data acquisition, standardization, and use. In addition, there are critical aspects for limited number of datasets available, as the number of possible data sources to use, the link and the ease of access to different data sources, data quality and the frequency of data updates, the database extension and integration, data import, export capabilities, the third-party data, access use, issues, quality, and simultaneous availability. Data are an instrument, not a goal, and they do not speak for themselves. Another important item is the model building. A digital twin seems to refer to any system mimicking the operation of another as a model that constitutes a simplification and abstraction of the structure and processes defining the system in which it is paralleled or compared to. Models are, by their nature, simplifications of reality. They should never aim at fully replicating the original system in the same detail. If that is the case, it would be useless and cease to be a model. Therefore, a model never perfectly mirrors a given system. This automatically makes it intrinsically different from the original one. The primary function of a digital twin addresses is by being descriptive in nature. In fact, it allows accurate operation descriptions of the assets considered through physics-based models and data-driven analytics. Even though creating a digital twin is not a simple task due to the need for accurate and up-to-date data and models that can represent the real object or reality being studied, there are several benefits to its use, as the continuous improvement, the predictive, since using various modeling techniques, the digital twin model can be used to predict the future state of the assets and the impact of its disruptions. The possibility of creating what-if analysis, since it's easy to interact with the digital twin and simulate different scenarios to identify the best actions to be then applied on the physical twin. Its visibility. The digital twin enables visibility and transparency in the operations of the machines and the assets being analyzed. Insights. A digital twin model can be used as a communication and documentation mechanism to understand as well to explain the behaviors of an individual or a system. System integration. The digital twin model can be used to be connected with the back-end business applications to achieve business outcomes in the context of supply chain operations, for example. Disruptive business model. The digital twin not only boosts the traditional business models and value chains, but also expands them by developing new value creation mechanisms via data-driven or product-as-service business models. We can also enlist some important challenges when creating a digital twin, as how to accurately capture the physical properties. A digital twin technology should be able to model both simple objects, like a vehicle, an airplane, a building, or a human being, or even complex objects relationships, like shopping processes, irrigation system, a store, and a whole city, for example. And this should be done by accurately capturing their physical properties, simulating their behaviors, and adjusting to their scale. And this is a very difficult task. It also needs to automatic update in real time, because it should be a self-informed system of its size and functionality changes in real time, and changes are altered when required. Availability of data and the danger of inaccurately representing an object using digital twin. The biggest concern most business owners who are interested in this technology have is the risk of misrepresenting the object or system they want to replicate using this technology. Considering the fact that there is not much information regarding how accurate the twin is compared to its physical counterpart, it makes this process very challenging. There are also conflict detection and resolving. It should be able to detect and react to changes in real-time environment. The system should also be able to identify and resolve execution differences so that communications are consistent and always accurate. The accuracy of future scenario simulation using digital twin. The other major concern that troubles most company owners who are keen on trying out digital twin is doubt regarding the overall accuracy of the simulation the technology will build, which are the models that we use to create this digital twin. Hardware and connectivity. Many digital twin candidates assets are not stationary applications. Providing real-time connectivity to assets that might be constantly moving or in remote areas is very challenging. Personal. Successful implementation of digital twin requires a set of skills for which a set of personnel must be properly trained. And last, security. It's important to ensure that security of the data management systems in order to avoid data loss or other possible damage. This is even important when we are dealing with data from people or consumers or personal data from people from a city. In conclusion, we can affirm two main things. Data creation is fundamental for digital twins, and it should be constantly updated. Models. When choosing a model, make sure that it can represent the reality being studied and can provide important insights to a possible what-if scenarios. These two main things, together with the other main challenges also listed in this class, an accurate digital twin system can be created. Thank you very much for your attention. Don't hesitate to contact me and visit our project website.